Assalamu'alaikum warahmatullahi wabarakatuh. First of all, let's thanks to our God, Allah Subhanahu wa Ta'ala, the Lord of the world, who has given us mercies and blessings, so you can watch this video from your home without any troubles and obstacles. Secondly, may peace and salawat always be with our Prophet Muhammad Sallallahu Alaihi Wasallam, who has guided us from the darkness to the brightness of Tawhid. Alright, everyone. So in this WTT, and also I as the host will sharing about mastering development. Okay, so without further also let's open our weekend English talk by reciting basmalah. Bismillah. Okay, and alright, before we start weekend teach talk series, I will introduce we first. My name is Khaizuran Malvin, 10th grade student from Idain Boarding School Solo, as was in this series. And as in a facilitator, Rafif Pranaja from 10th grade will share you about mastering web development. So for Rafif Pranaja, it's time yours.
Okay. Bismillah. Assalamualaikum warahmatullahi wabarakatuh. So, in here, I will be the speaker for tonight's WTT, and the material that I will be bringing up to you is demystifying web development tech stack, or in simple terms, I will be telling you the explanation of web development tech stack. So, let me see. Okay. Okay, so we start. So let's first things first. I will be opening. Well, what is the term tech stack? Well, the term tech stack might sound intimidating, especially if you're new to development, or perhaps you're a project manager, designer, or business stakeholder trying to understand the technical landscape better. Well, the goal of this presentation is to break down these components, break down this complexity into digestible components. We'll explore what a tech stack is, why it's so crucial, and the various layers layers and technologies involved. Over the next few slides, we'll journey from the user-facing front end to the server-side backend, touching upon databases, APIs, and popular full-stack combinations. We will also discuss key factors in choosing the right stack and look at some modern architectural design trends shaping the future of web development. Think of this session as building foundational understanding. We are not aiming to make you an expert in every technology overnight, of course, but rather to equip you with the knowledge to understand how different tools and technologies work together harmoniously to create powerful, efficient, and scalable web applications. This understanding is vital whether you're planning to your next project, looking to enhance an existing one, or simply aiming to have more informed conversation with non-technical teams. And by the end of this presentation, I hope that you have a clearer picture of the web development ecosystem and feel more confident in making or contributing to technology choices. So let's begin to the next card. Well, so what exactly is a tech stack? Well, in essence, a tech stack is a combination of all software products and programming languages used to create and run web applications. As the slide says, it's a set of technologies that powers a website application from the front end to the back end. I like the analogies provided here. It's similar to a skyscraper's building or a recipe's ingredients. Just as an architect will build a skyscraper with a bamboo, or a chef will make a cake with salt instead of sugar. The choices in technologies in your stack is fundamental to the final product. Now, why does this matter so much? The key impacts section highlights this well. Your tech stack choices have far-reaching consequences. Well, first thing first is performance. The right technologies can make your application fast and responsive. A poorly chosen stack can lead to sluggish load times and a very frustrating user experience. For instance, A language efficient at handling concurrent requests might be crucial for a high-traffic application. And then there's scalability. As your user base grows or your application feature expands, can your tech stack handle the increased load or not? Scalability isn't just about handling more users. It's about doing so cost efficiently and without a complete re-architecture. And then there's also speed and cost of development and maintenance. Some stacks allow for rapid development, getting your product to market faster. Others might have steeper learning curves or require more specialized, potentially expensive talents. Maintenance costs also vary. Well supported, documented technologies are generally easier and cheaper to maintain. And then there's also security, maintainability, and hiring capabilities. And then this brings us to the selection principle. You must remember that you must always prioritize fit over hype. It's easy to get caught in the latest technology trends, but the best stack is the one that aligns with your project's specific needs, your team's expertise, and your business goals. Don't choose a technology just because it's popular. Choose it because it solves a problem for you. Well, and understanding your tech stack isn't just a technical exercise. It's crucial for making informed decisions throughout the development process. Each component plays a vital role in how your application performs, scales, and evolves over time. Choosing wisely at the outset can save significant time, money, and headache down the line. And then for the next, there is, yes, anatomy of a web application, basically the core layer. Well, to better understand a tech stack, it is helpful to dissect a typical web application into its core layers. While specifics can be vary, most modern web applications consist of these four fundamental layers working in concert. First is the front end. This is the tip of the iceberg, the part of the application that users directly see and interact with. It's all about the user experience, or in short term, UI. And that's also the user experience. Think about everything that you click, scroll through, or input into a website. That's the front end. It runs on the user's website browser and is responsible for presenting data and capturing user input. The primary goal here is to create an intuitive, accessible, and of course, an engaging experience for all the users that access your application or your website. And the second is APIs, or is an abbreviation of Application Programming Interfaces. APIs are the unsung heroes of modern web development. They act as messengers or intermediaries, allowing for different software components to communicate and exchange data. In the context of our layers, APIs connect the front end to the back end. For example, when you submit a form on a website, which is basically the front end, an API calls is often made to the back end process to process that information. APIs aren't just for internal communication, they also enable your application to interact with third-party services like payment gateways, social media platforms, mapping service, or even in artificial intelligence through standardized interfaces. And the third, there is also the backend. This is the engine room of your application. It resides on the server and is responsible for all the server-side logic, data processing, and core functionality that users don't directly see. This includes things like user authentication, which means that verifying who you say you are, authorization, what you're allowed to do, business logic, the specific rules and processes of your application, and managing data interaction with the database. If the front end is what you see, the back end is simply how it works. And then, of course, there is also the number 4, which is basically the database. This is where the application data is stored, organized, and managed. This could be user profiles, product information, content, transaction records, and anything that needs to be persisted and retrieved. The backend interacts with the database to read, write, update, and delete data as needed. The choice of database is a critical part of the tech stack, influencing how data is structured, accessed, and scaled. As the slide mentions, these 4 core layers work together to create a complete web application. Each layer has its own set of technologies, programming language, frameworks, and best practices, which we will explore in the following slides. Understanding this architecture helps in conceptualizing how different parts of the tech stack contribute to the overall system of your application. And the next is a deeper dive into the front layer. The front layer that we will discuss is the front end. This is where the user experience is crafted. At the very heart of this front end, at the very heart of every front end, there are three core technologies. First is HTML, or in the long term, hypertext markup language. This is the backbone, the fundamental structure of a web page. Think of it as the skeleton of your body. HTML defines the elements on the page. It's like the headings, the paragraph, your image. There are also links, forms, and so on. It provides the meaning and organization of the content. And then, of course, there's also the CSS, or cascading style sheets. If HTML is the skeleton, CSS is your skin, clothing, and style. It's responsible for the visual representation of the HTML elements. It's like the colors, the fonts, the layouts, spacing, and of course, responsiveness across different screen sizes like phones, tablets, or anything else. CSS makes the website look beautiful and engaging. And then the third one is JavaScript, or usually shortened as JS. This is the C in HTML, CSS, JavaScript. It brings interactivity and dynamic behavior to the web pages. While HTML provides the structure of the skeleton and CSS provides your style of clothing, JavaScript made complex things happen. Think of animations, form validation, dynamic content updates without reloading the page, and of course, complex user interactions. That's JavaScript at work. These three technologies are the absolute foundation. Regardless of any advanced tool or frameworks used, they all ultimately boil down to generating HTML, CSS, and JavaScript so that the browser can understand and render properly. Building on these technologies, we have frameworks and libraries. These are collections of pre-written code, tools, and of course conventions that help developers build complex user interfaces more efficiently and in more structured manner. They provide solutions to common front-end challenges, and some popular ones include React, developed by Facebook. React is a JavaScript library for building user interfaces, particularly as single-page applications. It's known for its component-based architecture, where you build encapsulated components that manage their own state, then compose them to make complex UIs. It is very flexible and have vast ecosystem. And then there's also Angular, which is developed by Google. Well, Angular is a comprehensive, full-feature framework. It is more opinionated than React, meaning it provides more structure and built-in solutions for things like routing, state management, and form handling. It's often favored for large enterprise-level applications. Or then also Vue.js, or often just called Vue. Vue is known for being progressive, really easy to learn, and highly performant. It strikes a balance between the flexibility of React and the comprehensiveness nature of Angular, making it a popular choice for a wide range of projects. And then there's also Svelte. Svelte takes a different approach. Instead of doing much of its work in the browser like React, Angular, and Vue, Svelte is a compiler that converts your components into highly efficient, imperative JavaScript code at build time. This will result in smaller bundle sizes and faster performance overall. Well, the slide also notes an important trend. Modern development increasingly focuses on API first and single page application, or SPA, design patterns. SPAs load a single HTML page and dynamically update content as the user interacts with the app, providing a smoother, more app-like experience. An API first approach means the back end is designed around providing data through APIs, which the front end and potentially other clients like mobile apps consumes. This decoupling is a hallmark of modern front end architecture. And then let's go on to the next slide, which is the back end, the languages, frameworks, and servers. Let's move to behind the scenes to the back. This is the powerhouse that handles the application logic, data processing, and of course, interaction with the database. The choice of backend language and framework is critical, as it dictates how your server-side operations are built and managed. Here are some prominent options for the backend. There is Node.js plus Express. Node.js is a JavaScript runtime environment that allows you to run JavaScript code on the server. This is a game changer because it means developer can use JavaScript for both front end and back end. Developers can use JavaScript for both end and back end development, full stack JavaScript, Express.js, and the next is Express.js or simply Express. Express is a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile applications. It is particularly excellent for building APIs and real-time applications like chat apps or live streaming devices or services thanks to Node.js non-blocking event-driven architecture. There is also Python for the backend. Python is renowned for its readability, versatility, and extensive libraries. In web development, there are two popular Python frameworks, which are Django, a high-level, fully featured framework that encourages rapid development and clean, pragmatic design. It follows the batteries included philosophy, providing many common web development tools out of the box, like an ORM, Object Relational Mapper, admin panel, and of course, a templating engine. There's also Flask, a micro framework, meaning it's more lightweight and provides the essentials. This gives developers more flexibility to choose their own tools and libraries, making it suitable for smaller applications or more custom solutions. And for the other options, there are also a lot, or quite a bit actually. The backend landscape is of course diverse. Other powerful choices include Ruby on Rails, or often just called Rails, a popular framework within Ruby, known for its convention over configuration philosophy and developer productivity. There's also Spring Boot for Java, widely used in enterprise environments. Spring Boot simplifies the development of standalone, production-grade Spring-based application, production-grade Spring-based applications. Java's strengths are its performance, scalability, and large ecosystem. And then, of course, the most popular in Indonesia, there are also Laravel, that uses PHP. Laravel is a modern PHP framework with an elegant syntax, known for its rich feature sets, and developer-friendly tools. PHP itself has powered a significant portion of the web for decades. And then, of course, one of the hardest one is Golang, which is developed by Google. Go, or simply Golang, is known for its simplicity, efficiency, and strong support for concurrency, making it excellent for high-performance services and microservices. And of course, finally, we have the server types. There are static servers, which mean that these servers deliver pre-built files, HTML, CSS, JavaScript, images, directly to the client's browser as they are stored on the server. There is no server-side processing of the content itself before the delivery. And then, of course, there is the dynamic servers. These servers generate content on demand based on requests. This often involves fetching data from a database, processing it through backend logic, and then constructing an HTML page or API response to send to the client. Most complex web applications, of course, use these servers, not the static ones. They use dynamics. As the slides conclude, backend technologies handle critical responsibilities including authentication, business logic, database access, and serving APIs to front-end applications. The backend is truly the backbone that makes the interactive front-end experience possible and, of course, meaningful. And then continuing our journey through the tech stack, we arrive at databases and APIs, some crucial opponents for data management and communication. First, let's start with the databases, which is one of my favorite parts actually. This is where your application persistent data lives. There are two main categories. There is SQL databases or relational databases in other words. For example, there are PostgreSQL, MySQL, Oracle, and of course SQL Server. And then for SQL databases has a structured data. Data is organized into tables with predefined schemas, columns, and data types usually. Think of it as spreadsheet with strict rules. Of course, they're ACID compliant. This is a set of properties or the atomicity, consistency, isolation, durability that guarantee reliable transaction processing. This is a very important for applications where data integrity is paramount, like financial systems, for example. And of course, it has relational model. Data in different tables can be linked together using relationship, or in example, a users table linked to an orders table. SQL, or abbreviation of structured query language, is used to query and manipulate this data itself. And then for the next one, there is no SQL databases or non-relational databases. For example, MongoDB, document or DB means document database, Redis or key value store, and Cassandra, a column family store. And the last there is also Neo4j, a graph database. It is very scalable, often designed to scale out horizontally, adding more servers more easily than traditional SQL databases, making them very suitable for fairly large data sets and high traffic. And it's very flexible, and it has a flexible schema. They don't typically require a fixed schema. This allows for more agile development and handling of diverse or evolving data structures. For example, in a document database like MongoDB, data is stored in JSON-like documents, and each document can has a different structure. There is also various data models. NoSQL is an umbrella term for covering different models like document, key value, white column, graph, each suited for different types of data and access patterns. The slide notes an interesting trend. A notable trend is SQL databases now supporting JSON data types, blurring the line between relational and document databases. This gives developers more flexibility within the familiar SQL environment. Well, and then continuing from database, now let's talk about APIs, or again, is a short term for application programming interfaces. Again, but focusing on common types used in web development. There is REST APIs, representational state transfer. It's resource-based. Data is exposed as resources, for example, /users, /products, stuff like that can be acted upon using standard HTTP methods like get, post, put, and delete. It is widely adopted. REST has been the dominant architectural style for building web APIs for many years due to its simplicity and alignment with HTTP. It is stateless, which means that each request from a client to the server must contain all the information needed to understand this request. The server does not store any client context between requests. And then a standardized method uses familiar HTTP verbs, making it relatively easy to understand and use for intermediate to professional programmers. And then for the next, they are GraphQL. It is query-based, developed by Facebook. GraphSQL is a query language for your API and a server-side runtime for executing those queries. It has precise data fetching, unlike REST, where you often get a fixed data structure for an endpoint, sometimes overfetching or underfetching data. GraphQL allows clients to request only the data that they need and get it all in a single request. it has a single endpoint. Typically, a GraphQL API has a single endpoint, and clients send queries to this endpoint specifying their data requirements. And of course, it's strongly typed. GraphQL APIs are built around a schema that defines the types of data available, which enables powerful developer tools and validation. APIs are essential for enabling seamless data flow from the front end, back end, and potentially other microservices or third-party services, creating a well-orchestrated application. Now that we have looked at the individual layers, front end, back end, databases, and APIs, let's see how they come together in a well-known, together in what are known as full stack combinations or stacks. Sorry. Well, stacks are popular bundles of technologies that are proven to work well together. Using a well-known stack can offer benefits like a strong community support, readily available documentation, and of course, a larger pool of developers familiar with that specific combination. Well, here I have prepared for you some common examples. There are MERN stack, MEAN stack, PERN, LAMP, and of course, Jamstack. Let us start from the MERN stack, or stands for MongoDB, Express.js, React, and Node. MongoDB is a NoSQL document database. Express.js, a back-end web framework for Node.js. React is a front-end JavaScript library. And finally, Node.js, a JavaScript runtime environment for the backend. This is a JavaScript-centric stack, meaning you can use JavaScript across the entire application, be it the front-end, back-end, or even for interacting with MongoDB can be used JavaScript for it. It is popular for modern web applications, especially those benefiting from flexible data models and rapid development cycles. Then the next, there is MEEN stack. It stands for MongoDB, Express, Angular, and Node. Very similar to MERN actually. The key difference that is the use of Angular for the front end. Angular is known for being more structured and opinionated, which can be beneficial for larger teams and complex applications requiring a more standardized approach. The next is PERN stack. It uses PostgreSQL, Express.js, React, and Node. The PERN stack is just like MERN stack, but substitutes MongoDB with PostgreSQL. This is a great choice for applications that require robust data integrity, complex querying capabilities, and of course, transactional support of a relational database, while still leveraging the modern JavaScript ecosystem for the front end and the back end logic. And then, of course, the most interesting one is the LAMP stack. It uses Linux, Apache, MySQL, and PHP, or sometimes Python or Perl. Linux is used as the operating system. Apache is the web server software. MySQL is a popular open source SQL database. And PHP, or sometimes Python or Perl, is the backend programming language. The LAMP stack is a true veteran in the web development world. It has powered a vast number of websites and applications for decades and is still widely used, especially for content management systems like WordPress. It is known for its stability, cost effectiveness, which means that all the components are open source, so it's freely edited, and extensive community support. And the last one is Jamstack, for the most popular ones. Jamstack stands for JavaScript for the client-side interactivity, APIs for server-side processes and accessing data, markup, pre-built HTML, often generated using a static site generator. Jamstack is a modern architectural approach focusing on delivering pre-rendered static files to a CDN, or stands for Content Delivery Network. Dynamic functionalities are handled through JavaScript and, of course, reusable APIs. This approach often leads to excellent performance, higher security as there's less server-side processing during the request, and, of course, better scalability. These are just a few examples that I can show you. There are lots and lots of other combinations out there, and teams often customize these stacks or create their own based on their specific needs. The key takeaway is that these stacks represent proven synergic combinations of technologies designed to build complete web applications. And of course, how do you choose the right stack? Where here I will present to you the key factors. We have seen the layers, the technologies, and some popular combination. But how do you actually choose the right stack for your project? Well, this is a critical decision, and it's not always straightforward. This slide presents a pyramid of key factors to consider, which provides a great framework for this decision-making process. Let's break this down, starting from the top to the most bottom one, which represent the most immediate considerations. So, the most immediate one is the project requirements. This is paramount. What does your application need to do? Are there specific needs like real-time features, like live chat or notifications? Technologies like Node.js excel here. Is it an e-commerce platform requiring complex transaction management and security? A robust relational database and secure backend framework will be essential for it. What kind of data will you be handling? Is it highly structured or more fluid and document-like? This will influence your database choice. And of course, the nature of the project, its complexity, expected user load, and core functionalities will heavily guide your technology choices. And the second to consider is team experience. Your team's existing skills and their ability to learn new technologies are also crucial. Do you have developers proficient in Python, Java, or JavaScript? Leveraging existing expertise can significantly speed up development and reduce costs. Consider the learning curve also. Introducing a completely new and complex technology might slow down the initial progress, and sometimes it's a trade-off. A new technology may be better for the long-term fit, but you need to factor in the time and resource for training. And then, of course, scalability and performance. You must think about the future of your application. How much growth do you anticipate in terms of user, data, and traffic? Your stack needs to be able to scale to meet these future demands. Some technologies are inherently more scalable than others. There's also what are the performances requirements? Does your application need to be lightning fast? Certain languages, frameworks, and architectural patterns are optimized for high performance, of course. There are also security and compliance. This is non-negotiable for many applications. What are some security implications of your chosen technologies? Are there known vulnerabilities? How active is the community in addressing these security issues? Are there any specific industry requirements or data protection regulations like GDPR or HIPAA that your application must comply with? Your tech stack must support this. And of course, the total cost. The foundation of many business decisions comes from here. There is development time, hosting, hiring, and of course, licensing costs. Well, the advice is on the bottom of my presentation is key. You must avoid choice paralysis by optimizing for your specific context rather than following trends blindly. The shiniest new technology isn't always the best fit. The right stack should align with your project goals and your team's capabilities and your business requirements. Furthermore, a strong community and ecosystem around your chosen technologies can provide long-term support and resources, which incredibly value for your troubleshooting. Beyond the individual technologies and stack, architectural patterns we choose build and deploy applications are also evolving. These slides highlight some key modern architecture and trends that are shaping how web applications are designed and developed. I want to shorten this up by only explaining what is important. So some architectural styles, there are three actually: monolithic, microservice, and serverless. The monolithic structure is simple to start, develop, and deploy initially, but as the application grows in complexity, it becomes difficult to scale. As for microservices, it is very highly scalable. You can scale only the services that need it. It is modular or easier to understand and maintain individual service. It offers flexibility also in choosing different technologies for different services, but it adds complexity in terms of managing multiple services, inter-service communication, and distributed data management and operational overhead. And then for the last, there is serverless. It is auto-scaled, so a function runs on demand and scale automatically. You pay only for what you need. So when your code is running, so that's what you paid for. And of course, reduce operational burden. But it can lead to vendor lock-in. potential for cold starts, latency if a function hasn't been run recently, and of course, limitation on execution time and resources for individual functions. Beyond this architectural, there are several emerging trends to watch. There are WebAssembly, progressive web apps, AI ML integration, or basically artificial intelligence and machine learning, low code or no code tools that uses platforms that allows user to build application with minimal or no traditional programming, often using visual interfaces and pre-built components. And of course, there are CI/CD and DevOps practices. CI/CD stands for continuous integration and continuous delivery for the CD. And of course, on the last one, there's conclusions. We have covered a lot of ground today, from a fundamental definition of a tech stack to its core layers, specific technologies and popular combination, and the evolving architectural landscape. So the recap is the complex stack is carefully chosen combination of front-end technologies like HTML, CSS, JavaScript, and frameworks like React and Angular. Back-end technologies like languages like Node.js, Python, Java, and their frameworks. Databases, SQL or NoSQL, and APIs like REST or GraphQL. Together, these components create the web application we use every day. Crucially, the choices you make regarding your tech stack directly and profoundly impact key aspects of your application. That is performance, user experience, scalability, and cost. Well, perhaps the most important message to remember that is that there's no one size fits all solution in web development. The best tech stack is entirely contextual, where works brilliantly for small startups. MVP might be entirely unsuitable for a large enterprise global platform. Therefore, the best approach is to make intentional, informed decisions based on your specific project needs and your team's capabilities, your budgets, and your long-term goals, rather than blindly following the latest trends or what seems most popular for the moment. Whether you're a developer, a project manager, a designer, or a business leader, a solid understanding of these tech stacks will empower you to contribute more efficiently to the creation of successful web application. Wow. So, I must say thank you for your time and attention for the whole 32 minutes that I spoke nonstop. I hope this presentation has helped you to demystify the web development tech stack and provide you with valuable insights. The last I say, that's the end for my presentation. Thank you. Really, thank you for listening. I will give the time back to my host over here to end our session. Thank you.
Alhamdulillah, thank you for Rafif Pranaja explanation about the mastering the web development. Hopefully, what has been delivered by Rafif Pranaja can provide new inspiration, broaden horizons, and becomes valuable professions for all of us in moving forward. We believe that every meeting brings lessons, and every team that is raised opens the way for better change. And also, thank you for the attention and questions and great togetherness and of the audience. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.